say thank you to Brett and Heindel for making this a reality. I'll turn it over to them. Hello, I'm Dave Prows. I guess here's our outline. I guess we'll skip this slide though. So I'm going to introduce the team to start off with. So I'm Dave Prows. I was originally tasked with coming up with a new badge for this year. So if you're, well, I'll go into my presentation in a minute. Sorry, I was starting to do it. All right, so I was product owner. Brett Gilsinger, raise your hand. He was our hardware designer, so he designed the hardware of the badge. Lou Gilsinger, sitting next to him was the software proto, so the prototype initially of that. Stephen, I don't know your last name, is it Heindel? Okay. He's software app and the firmware, helped with that quite a bit. And then Tad Turner, he did a lot of the CTF part of it and more than that, but helped design the firmware and compile that. Yeah, really cool things. These gentlemen have spent, I don't know how many hours, we might ask them that later, designing this and doing a lot of troubleshooting and all that. So we'll get into that in our presentation, which brings us to the badge vision. So now I can start my presentation. So if you remember back for the last 2 years, we had the badge. So now not everybody had the case. This is mine from 2023. I guess I have stuff here. So we were going from that, and Matt asked me to take it on this year and come up with something new. Gave me a budget that we blew out of the water, thanks to Gigtel. Without them, we wouldn't have been able to have this type of badge. I kind of stumbled into doing the badges initially back in 2023 when we were coming out with the badges. We basically were going to let everybody figure it out. So you're going to get a badge at registration and go and figure it out. I didn't really like that idea when I found out about it, so I started writing some code and came up with the registration system you saw out there. So that's the one I came up with in 2023. There's been some tweaks to it, but just to do some basic badge and put this on the badge at registration. And then we continued that in 2024. So you can see 2 different iterations that I did on mine. I switched it to a dark mode, which is much better. Dark should always be the default. But if you're a programmer, remember that, dark mode, default. Sorry. This is a pet peeve of mine. And of course, these slides are in light mode. But anyway, Brett. All right, so come into the requirements for this year. We were given 2 requirements for this year's badge. One is that it had your name on it, and that it had possibly the company name and your title. Now, obviously, we didn't do the title this year, but you could go in and hack that. But that was just a possibility. Those were just our 2 requirements, and we had a small budget to get into. So I did some searching online, trying to find something to design for the budget I had, which was $2,000 for over 200 badges, which is not a lot of money for a badge, electronic badge. What I was finding is they were around $18 to pay somebody to go out and do one, and that just wasn't going to cut it. So we're going to have to design our own. Well, I met Brett through Fort Wayne BMUG, and he had supplied me some boards over the years, and so I'm like, hey, I know he's designed boards, let's contact him and see if he could help with it. So I contacted Brett with these 2 requirements, and you see what we came out with. So, I mean, just way blew it out, which was, the other requirement had to have LEDs. Everything has to have LEDs, right? So, and I think we accomplished it. So this is the badge we have today. We went through a lot of different iterations, which we'll talk about through the presentations. So that's all I have for my presentation. So I'll have Brett come up and do his. Make sure to come by and see us in the badge hacking village if you are curious about how to do more with it, we can help you learn how to do some of that. There are some QR codes around if you haven't seen on how to control your badge, just the basics. If you go to the QR code or go to our GitHub page, which I probably should have put in our slides, but hindsight. But there are around, there's some at the registration table, there's some down in CTF, and you'll see it on some of the signs. Just to go in on the README page, so the first page you go to, just scroll down to the bottom, or not the very bottom, but if you scroll down, the top of the README file shows what the buttons are just as generalizations. And then you scroll down a little bit more, there's the actual badge app, which is what you see on the screen here, and that's what your badge is defaulted to, what the buttons do within that application. So, all right, I'm gonna turn it over to Brett.
Morning, everyone. So, hardware. I want to start off by saying I am not a professional hardware engineer of any kind. This is a hobby. I like doing it, and I like passing random boards out to people that I meet, and that's how I kind of got into this thing. But it's this was a really cool project actually. I had a lot of fun doing it. So I'm going to talk a little bit about the hardware design, kind of the process that I go through when I do hardware design, and I'm going to get into some of the specifics of the board and kind of what it can do. So let's get into it. So first is my kind of process, and I'm going to talk about the tools I use and all that stuff, but first you got to think about what am I doing and why am I doing it. I like to do this stuff because I just enjoy it. Maybe that's weird, I don't know. But it's a hobby, like I said, and I like to learn things about this. So when I design a new board, it's usually to figure out how to do something with that part that I've discovered. Like an ESP32, which is on this. I want to learn how do I make an ESP32 work? Like what are all the the auxiliary components that it needs to actually function? And I'll make a basic board and make it work. So develop the concept. What am I trying to achieve? So for this, obviously, I'm trying to make a badge. And then after that, I design the initial schematic. And the initial schematic is not something that you're going to get right the first time. It's also not something that you can just put in ChatGPT and say, hey, make me a schematic for this. That will 100% of the time be wrong. GPT is good at a lot of things, but making an actual circuit diagram that's correct, it's not very good. Now, you can't take a picture of it and post it in there and say, hey, did I mess anything up in here? And it will usually find the little items that you might have missed. So I definitely do that. So the initial schematic, you establish what components are required and how they're going to actually work together functionally. Once you get done with the schematic, you start the layout. All right, so you start to position the parts and pieces on the board in the software where you want them to be. And then at that point, you realize your schematic's wrong because you're not going to be able to get this trace from here to there efficiently at all. So if you think about like GPIO pins on an ESP, and they come off of all sides and random locations, and you may have designed the schematic to use GPIO 33 and 34 on this particular component, but then when you actually lay them out on the board, it's a whole lot easier just to use GPIO 10 and 11. So that's when you go back after you started the layout and you enhance the schematic and you update and correct all those things. Then you go back to the layout and you design your traces and see if everything kind of fits together. After that, you go to prototyping. And prototyping, there's a couple of different ways to do this. There's a lot of people who are thorough and professional and like breadboard the whole thing out and make a working prototype. And then there's people that kind of fly by the seat of their pants like me. I just order the board and see if it works. And then I reorder it later when it doesn't. But there's two different types of prototyping. There's PCB only, and then there's PCBA, which is the actual assembly part. So PCB only, that's, you can basically come up with your board layout and you can order the board and it will just come as a board. It'll have the solder mask, it'll have the silk screen, it'll have, just the board and all the holes drilled in it. You've got to solder on all the components yourself. If you're good at soldering, if you have a lot of patience, this is the way to go because it's really cheap. It only costs a few dollars a board to do this. Even shipped, it's like a few dollars a board. But it takes a lot of work, and if you're going to do a bunch of them, obviously that's really difficult. PCBA, PCB assembly, that's much more expensive, but the boards come with all the components on them. Everything's sourced by the manufacturer, and it's basically ready to test right out of the box, or ready to use right out of the box. And that's obviously costs a lot more to get that done, but like in the case of these, if you're making 250 of them, these are PCBA. I'm not going to solder on all the components on this board for 250 of these things. So yeah, that's prototype. Tools and suppliers. So a lot of people ask me this question, like what software do you use? How do you kind of source the components, all that stuff? There's a couple of different softwares. So these are just the ones that I use. There's actually a lot out there. So there's EasyEDA. This is a free application. I use EasyEDA Pro. That's the one I prefer. But EasyEDA, the standard version and the Pro version are free. They're provided by, I think the company is JLC PCB. That's who did the PCB assembly on these. I'm pretty sure they're the ones who actually wrote that software because it's so tightly integrated. But that's free, but it's not open source. There's KiCad. I think it's KiCad or KiCad. Either way, that is free and open source, and it's actually a really good one. I've used it, I like it, but the thing that it kind of lacks is the supplier integration, and I'll kind of talk about that in a minute. But it is a really good one. Altium Designer, I actually use this one too. I've tried it. So I was recently going to school to get my master's, so I got an education discount. I got to download Altium Designer for free. This software costs like $5 grand a year. This is like if you're working for Apple or like a real equipment manufacturer, you're going to be using Altium Designer. So I thought, yeah, I'll download it, I'll try it out. When I'm done with my degree, I obviously won't keep it because it's a lot of money. But I actually got in and I'm not sure I really liked it. I think there's a much bigger learning curve to using something like that. Like this is the true professional software. Like you really have to know what you're doing, and you have to have been doing it for years. And that's just not something a hobbyist like me is going to do. I also use a lot of calculators, so calculating voltage dividers, resistance, calculating the dropper resistor on an LED, to all this fun Ohm's law stuff, even calculating the width of PCB traces on the board to carry the amount of current that you want them to carry. You really kind of need calculators for that unless you're just a real math nerd, which I'm not. I would much rather just use a calculator. So DigiKey has a lot of good calculators, and then the Saturn PCB toolkit, this thing is awesome. Like it is a Windows only application, which I'm not a huge fan of, but this is great. Like it'll basically calculate any aspect of a PCB that you need to calculate. And then there's data sheets. How many people like reading data sheets of electronic components out there? Anybody? Hey, you got one, awesome. Yeah, so you really have to read the data sheets, unfortunately. That's just part of it. I think the data sheet for the ESP32 is it's like 84 pages for just for the basic one, and that's not even getting into the real detail. So you have to be able to go through and search and find the aspects of that part that are going to make you understand how to make an interface to another part. It's just the way it is. And then part suppliers. So I kind of talked about EasyEDA before, and the reason why I like EasyEDA is because they're so tightly integrated with LCSC as a supplier. So you can go into the EDA side. EDA stands for Electronics Design Automation. So that's basically the software where you're designing all of this, the schematic and the layout, and then actually produces the files that you send off to the manufacturer to order it. The nice thing about EasyEDA is it's integrated with the parts supplier, so you can actually search for the part that you want within the EDA application, and it'll give you the layout, it'll give you the schematic symbol, it'll give you all that stuff, and you don't have to go out and hunt and find you find the layouts to make sure that it's going to fit right on the PCB. That's kind of the reason why I use that. They are based in China though, which makes it difficult, especially with tariffs. That's a whole other story. But another supplier is DigiKey. If I'm going to make like a PCB only design where I'm going to just order the PCB and then put the parts on myself and solder it, I usually order it from DigiKey. If I can't find it at DigiKey, I go to Mouser. So all good suppliers. All right, what's next? Okay, schematic. I'm going to go over like a couple of small pieces here, so don't worry, you don't have to memorize all this. This is just a picture of the overall schematic of the device. I'm going to kind of go through some of the important sections of the device that are kind of zoomed in so you can kind of see how it works. So that's the schematic. This is the layout, and this also is the Easy EDA software. So like over on the left, does this thing work? Over on the left, like over here, these are all the different revisions of this board. So this is the one that you all have around your neck. Most of you have around your neck is V4. There are some V3s floating around out there. Careful with the serial communication because sometimes it's not great. That's why there's a V4. But this is kind of the layout. So this is where you go in and you basically draw all your traces on here, and then you can put a silk screen over the top of it with an image. That's where the BSides came in, and then you can order it right out of the software. You can basically say generate files and order online, and it'll pipe it right over to JLC PCB, and boom, there you go, place order. All right, let's get into a few other things. So this is running an ESP32W Rover E8 N8R8. This is a 8 megabits of flash, 8 megabits of RAM ESP32 with a dual core 240 megahertz processor. It's got Wi-Fi, it's got Bluetooth, and probably a bunch of other things that I'm neglecting to mention. What should I talk about this processor? Anything specific I should mention here? There is a deep sleep mode. You probably all noticed that it does go to sleep. That's after about 2 minutes. If you give it a little shake, it'll wake up. That was kind of to try to save battery. One thing that I did run into a couple people already that their badges were kind of just randomly buzzing as I walked by them. Yeah, it's Tad. He's looking the other way because that's his CTF firmware that does that. If that does happen to you, there's a little button that says RST, the reset button. It'll stop buzzing. Okay, so that's the ESP. Let's see. How long have I been up here? What's the time check? I don't want to use all of our time. All right, this is the USB serial component. So if you plug into the USB-C port, you'll get access to the UART on the ESP. So you'll be able to actually issue MicroPython commands directly to it, which may be important for some things today. So that's the chip that's doing it. It's a CH340 is the chip that actually converts the USB to the serial TX and RX. Let's see, what's next? So power supply, not really happy with this power supply, to be honest. I would probably, this is something that I would probably change if I could change it at this point. If you touch this area, if you put your finger over that, the board will probably reboot. It's a switching power supply, which it really needs a switching power supply because I need boost buck, because my battery voltage is like 3.7 volts and I need 3.3 volts. So I may drop below the threshold of a low dropout regulator if I went with that, and I'd waste too much power if I did that anyway. But it's too sensitive. So basically all this does is it takes the battery voltage of anywhere between 3.2 to 4.2, which is all the way dead or all the way charged of a lithium polymer battery, and converts it to exactly 3.3 volts for everything on the board to use. And this is something that's important. It's the battery protection circuit. So basically this sits in between the battery and everything on the board, including the charging system. So this is the safety mechanism. If you leave it on charge for too long, if the battery charger goes wrong, if you leave the power on, this is going to keep the battery voltage within the limits that the battery can tolerate. It'll shut it off, basically, if it sees too much voltage or too little. Not much more to say about that. Battery charger circuit, TP4056. This is a simple IC, very easy to put together, that charges the battery at 900 milliamps, and it just does its job. There's two little lights down on the bottom of the board that will tell you right here, this LED here and this LED here. There's a red one and a green one. The red one means it's charging, the green one means it's charged. It's a very simple circuit. Works great though, I think. Your board also has an accelerometer. That's how it knows when to go to sleep. And there's also a level app in there. I don't know if anybody's played around with the badges very much, but if you hold the D button down until there'll be a menu that pops up, and you can go through and there's all kinds of apps in there. There's actually a level app where it's got a little dot on one of the screens and you can use it as a level. But it also has an interrupt pin, which we use that interrupt pin to do the wake function. So basically we program that accelerometer to basically send out a signal on that interrupt pin that goes into the ESP that wakes it up when it detects a certain threshold of movement. So it's a fun little chip. There's a lot in there. We actually did the battery monitor on that too because it had some additional I/O. So it has an ADC input right here. So the battery gauge is fed in from the accelerometer. And that's also on the I2C bus, or I2C, or integrated circuit bus, whatever you want to say it. I don't know what the proper terminology is, but that's just a 2-wire interface that goes around the board and interfaces with all these ICs. And this is at address 0x18. Let's see here. All right, expansion headers. There are 2 expansion headers on this board. One of the other requirements that David told me about was he wanted it to be hackable. And I agree with that. I think that's awesome, because if you're all taking these home, do something with it at home. Don't just throw it away. So there's 2 expansion headers, and this is the pinout of those expansion headers. They're up there at the top. There's quite a bit of I/O, and that I/O is provided by either the accelerometer in the form of the ADC2 and ADC3 of the accelerometer, and the I/O input-output expander, which is also on the I2C bus. That input-output expander gives 16 additional I/O ports that the ESP basically ran out on the ESP. Too many devices. So yeah, you can solder on your own devices onto those and have fun. And then of course the LEDs. You have to have LEDs. So this is it's basically just an RGB LED strip like you would buy off of Amazon or anywhere else. It's just in order, and you could actually load WLED on this board and drive this LED strip just like a WLED strip. So yeah, those are the RGB LEDs, and I think that's it for me. So if you could all do me a favor though, for the next presenter, wake your badge up, because they may be sending out some Bluetooth signals. Go ahead. This is Luke Gilsinger.
So, as he was talking about, I'm going to do some stuff with Bluetooth. The ESP32 has a Bluetooth and a Wi-Fi chip. So I hope this works. I'm going to push the button. All of the lights should turn on if I did this right.
There we go.
Almost.
Yeah,
Awesome.
So that works over Bluetooth advertisements. So it just advertises itself as a command to turn on all the lights. And there are some extra things as some sort of like ways to prevent other people from doing it. Because I don't want like during other presentations or something, people will tell you messing with the lights and like the CTF or something. But yeah, so one thing that I'm doing, that was the only time that it would ever work. So like if I push the button again, nothing happens because it's sent a flag in the ESP32 storage that basically says that command can never be used again. And another thing that I did, tried to do, I tried to make it so it will only go off from 10 to 11 since our presentation is during that. But I ended up just broadcasting a time that says it's 10:30 all the time. So that won't work. I did that this morning because I realized that if my badge resets at all, it would stop broadcasting the time and it would get off. So that's that. About the initial programming, one thing that I did, I chose the what framework we use. So I was originally going to use Arduino or ESP-IDF, so C++, but I also like, the rest of the team knows Python pretty well, but it's also like, I guess dynamic would be the good word, because like if you go into the settings app on your badge, you can just add apps into there, and you don't have to like compile it or anything. So we picked with, we chose MicroPython for that. One challenge we had with that though was the display driver, which I was thinking would make it so we couldn't use MicroPython at all, but there was someone, I think his name is Russ, he made a display driver for us that it acts as a C extension in MicroPython. So that worked pretty well. Ted can talk more about that because he had to compile the firmware which involved his C extension. But yeah, I did that. I did some of the other drivers too, like the accelerometer. I think I also started on the buttons, which all of the buttons except for the boot pin, which is button A, I think, are through the IO expander, which that is talked to over I2C. But yeah, I think Steven improved it a bit, my code, but yeah. We also, about the buttons, the GPIO buttons, which is just the boot pin, is through an interrupt. So it will, when it detects that the pin is high, it'll stop everything else that's on everything else that is running to handle that event that the button's been pressed. For the rest of the buttons though, the way we did it, we used a timer. So every like 10 milliseconds, I think, it checks to see if the buttons are pressed. The reason we did that instead of just using an interrupt on that, on the early versions of the board, the interrupt for the IO expander was not connected, and I don't think we got around to changing it. So there's that. I did the initial app framework, which I think in the V1 boards and maybe V2, it was just like there's 4 buttons, and then you push each one of the buttons and it would go to an app. So there's that. I also did Tetris, which was more difficult to code than I thought, because there's a lot of logic involved in that. I ended up just giving it to ChatGPT at one point and it did it all for me. But yeah, that's it. Steven did more of the app framework, so you can talk more about that.
All right, thanks, Luke. Yeah, you know, I put the slide as initial software development, but really, I mean, Luke did a bunch of software development along the way as well. So like, a lot of the software is definitely credited to him as well. So I found out about this project through the Discord. They were talking about this badge they were going to have, and I've been a software dev for about 13 years now, and I was like, oh, well, maybe I can help out a little bit. And one thing led to another, and we ended up creating actually a really comprehensive app framework for the badge. And one way that I approached that is we tried to talk about it in terms of what I would call user stories. Just like this, not working. So, but anyway, before I get to those, I want to talk about the loose goals I had. So the first issue we had is that it took a little while for the badge to start up. So I said, well, let's see if we can make this startup time faster. So we actually came up with a system where we actually don't, for those of you who know Python, we actually don't load all the Python modules at startup. We have an app cache that basically knows what they are, and if something changes about the file, it will investigate them and save them in the cache, but then we don't have to load them and investigate all at startup. So that was one of my first goals. And the second goal I wanted was a unified app design. I wanted apps to all have a similar interface. And so what that gave us is it gave us a way that, first of all, we can automatically populate the apps in the menu. So when you go to the menu on your badge, if you hold down that D button, it'll open the menu. And all of the apps you see there, that's just a single Python file. You don't have to register with anything. You just have to put a Python file in a specific folder on the board and an error from a certain class, and everything else just works. I'll show that in a little bit. For those of you who might want to hack on it software-wise, I think you'll really appreciate it. One of the things I added there, then in addition to that, was easy, persistent config. There's a lot of things you want to save on the badge. Obviously your name, right? When we reset, we want to save that information. So we have some configuration objects that are also part of that base app class, and I'll show an example of those. And then I also wanted to make this a really low barrier to entry. We want to make the apps really simple, easy to approach for someone who's maybe a little new to development. And so I think you'll find that we made that really, really straightforward. And if you're really interested in that and want to hear more about it, please stop by the CTF and Badge Hacking Village. I don't know how much I'm going to be there, but Tad will be there and he can definitely help you out, and there'll be other people there who'd be happy to help you out. I think this is a really great entry into software development. I've always found that when you deal with a physical device, it really helps because it's just so easy to think about the code in terms of the buttons and what's actually happening in the screens, and it really can connect a lot of things in your brain. So basically what I did was I decided, okay, what do we want this badge to do? And I divided it up into a series of user stories. Now, you usually don't give names to your user stories, but I thought this was a cute approach. So I'm concerned about Badge Barry, Tinker Tina, Script Kitty Sam, Hacker Hannah, and Embedded Eddie. So I'll talk about these 5 really quickly. Badge Barry, he wants a badge, and he wants it with his name on. Thanks, Dave, for taking care of that, the registration team. And he wants it to last all day. So thank you. Yeah, Sharpies don't need batteries, so we got a lot to compete against. So we have a large battery, thanks to Brett, that helps out with that. And then of course the sleep and wake detection, that's all Luke. I was really impressed with his implementation there. I've been doing software for a long time, and I think he did that really cleanly, and it's worked really well from what I can tell. So that's Badge Barry. So if you're Badge Barry, that's fine. Hopefully we got you covered. Tinker or Tina, okay, you want to play with your badge, you want to try some apps out. I would recommend you scan our QR code at the registration table, go to the GitHub README, it'll give you some information on how to use it. The most important thing is the menu button. That's the D button. Hold it down, takes you to the menu. And then you can use the up and down buttons, and you can select apps with the other big button there in the middle. Super easy to use. Now, Tinker or Tina might want to get a little more fancy. You can connect your badge to Wi-Fi. So you can configure your badge to connect to Wi-Fi, but then you got to figure out how to connect to the badge and use the serial port, and maybe you don't want to do that. So in the apps, there's a settings app. The settings app starts the badge as a Wi-Fi access point. It's got a QR code that shows you the screen. You can connect to that using your phone. You can scan the QR code. It's a Wi-Fi hotspot, and it'll connect to the badge. You can then visit a specific IP address on the badge, and there's a web server, and it actually serves up a page where you can configure things. I'll show you that in a second. So this is super, super helpful. So there's a web configuration component to it. Now this web configuration component actually inherits from the app configuration component that also does persistent config. And I'll show you how that works in just a second. We also want to make an onboard UI for configuration. We haven't gotten there yet. In our minds, this software is somewhat vague this year, so we appreciate you all trying it out and giving us some feedback. We're hoping this is going to be even better next year. So we don't have the global onboard configurations yet. There are some specialized configs. So Dave added some functionality where in the badge app, which when you go to the menu, you'll see there's an app called Badge. That's the app that your device starts with, right? So you can go back to that badge app. And there's some buttons you can play around with to adjust some colors in the badge app. So there's some specialized configuration in there. So if you want to go ahead and go to this level where you connect to it, you can start the settings app. That shows you the QR code. You then can scan the QR code and you can connect to it. When you go to, usually the badge serves up 192.168.4.1 to the users, but if you know a little bit of networking, you can figure that out. But usually that's the IP address. And if you go to the /config endpoint, you can select different apps that have been loaded, and it will show you the configuration variables for the app. So this configuration variable, this is for the badge app. This is how we programmed it. We programmed this configuration at registration time. You can see, and if you're not a developer, I know these look a little funny, but it's really not that complicated, right? At the very top, you see our first name, right? And then at the very bottom, the last name variable shows up there. So we're going to look at those. So like, first of all, anybody I think could edit this web page, right? It'd be really easy just to change those names, and you can configure this app. Any app could use this configuration framework, and I'll show you what that looks like. So if you want to hack on it and write your app, it's really, okay, I'll talk about a script kitty Sam. Like I said, I didn't talk about that yet, but this is the configuration framework, so keep this in mind. We're going to show you how we do all this in a little bit. So, script kitty Sam, he wants to write his own apps. He wants to connect his badge to his own Wi-Fi, so he can have internet at the same time. You can do that. You can load a Wi-Fi configuration file on. He can do some file-based configuration. Again, go to our GitHub, and you can see how you do this with a tool called MP Remote. This is one of the common tools that's used in the MicroPython ecosystem for interacting with the MicroPython board. It's super easy to use. We've got some examples there to help you get started. So he may also want to upload some scripts via the web server. Remember that web server I talked about? Whether you connect it to Wi-Fi or you do it at an access point, it's the same web server running on the device, and you can actually upload scripts to the web server. So this script kitty Sam, he may not want to get the full tooling for it. He may just want to actually write a single Python app for it. So back to that web framework. You can actually go to an endpoint of /add-app. You can copy an existing app that's already on the device, and then you can modify the Python, give it a new name, and submit it, and it will save it to the device. At that point, when you restart the device, the app directory cache will refresh, it'll add it to the menu, and your app will be in the menu. One Python file is all it takes. The only thing you need is you just happen to inherit from that base class. Everything else is handled for you. This UI is a little rough. We're hoping to make this better and a little more user-friendly as we go on. This is very much in beta, but we're trying. So, now we're into the Python code. So those of you who don't know programming, you might get a little lost here. I apologize. I'll try to make this brief. So all you have to do is you have to inherit from our specific app base class. This is the key to making all of this work. So as long as your class that you create inherits from that base class, you get all of this nice configuration stuff out of the box. You can then even give a name variable at the class level, and that will make that name available in the menu. That's how you'll select your app. So, for instance, there's the analog clock app, right? It's just right there, or the badge app, right? Those are in the menu. This Hello World app is in there. That was supposed to be a starter app that you can copy if you want. So that automatically populates the menu, all based off what's in this file and some dynamic kind of digging into the files. So back to that configuration page we talked about. We talked about that first name and that last name variable that are showing up in this web configuration page. All you have to do when you inherit from that base class is in your constructor, you're going to add some configuration variables. You're going to give it a name, so first name, last name, you're going to give it a value. At that point, everything else is handled. The smart configuration object figures out this is a string, it figures out how to serve it up to the web framework, it takes care of all that for you. Later on, in your update method, like when you're re-rendering the app, you can dereference those values out of the config. So that's also saving it on the file system to be persistent, it's making it on the web config, it's doing all that for you, and so if you know Python, you know this is actually a very simple way to use these. We've made it super, super friendly for someone just getting to the badge, that you get all those features out of the box. Okay, let's talk about Hacker Hannah. Hacker Hannah, she wants to actually use our app framework. Great, this is all available on GitHub, it's all public, so you want to write your apps that way. That'll really help because when you download our app framework, we have all of the typing information you need for that to be a really good experience in your normal code editor. So VS Code support is all built in. We've got extra typings to support our MicroPython drivers. So you can definitely hack in the framework this way. If you get the whole framework, you can access the drivers. You can play around with those. You can play around with some of the base framework properties as well. So we've got it together. All in GitHub. If you got to go, just go to GitHub. We've got a README there. This has actually been updated. This is an order snippet of it, but we've got a bunch of information explaining the repository, explaining how you get started. Again, anyone who's seen a GitHub page, this will seem very familiar. If you haven't seen this, don't let that be a barrier to entry. Don't let this feel foreign to you. This is super easy to hack on, and we'd love to help you get started. All right, and embedded edit. Embedded edit, you might want to add peripherals through Brett's expansion headers. Here's the thing with embedded edit. He wants to use the ESP-IDF framework. If you know what the ESP-IDF framework is, I don't need to explain anything else. I don't need to give you more instructions. You know what you're doing. So he wanted to reprogram the ESP32 using full-on C++ or even Rust. I put around using Rust in sports too. That's all I have. Oh yes, for embedded edit, we have the technical specifications. A lot of what Brent shared is in the GitHub as well. There's a separate hardware README that goes into details, has links to data sheets, all the information you want, the schematics are all there. Okay, that's my part.
All right, so I can walk us through a bit of the CTF code that was written. Basically, I've helped with the CTF since the beginning of the conference, and then this year, I mentioned to Dave that I wanted to work on the badges because they were so cool from last year. I spent most of the conference last year in the badge hacking area working on the badge, and I really liked MicroPython too. So I told Dave, I want to work on the badge. I'm also working on the CTF. And I suppose I shouldn't assume that everyone knows what a CTF is. What we have going on over on the opposite end of the building is a hacking competition. So anyone who enters can sign up for it, and then they're presented with challenges, okay? When you solve a challenge through either scripting or exploitation or any other way that involves you using your computer science brain, you get a flag. It's a string of characters, it's really, really long, so you can't guess it, but you know when you see it, and you submit that flag for points. Okay, last year we just dropped a file on the badge, and we wanted to make it so that if you connected to the badge, you got a few points. That's great. We want to take that idea to the next level this year, and so that's when I got involved, and I started to look at the badge, picked up my prototype copy of it, flashed the firmware on it, and I realized we were once again using MicroPython. So, this is where a lot of the problems kind of came out. One of the issues with languages like Python, and therefore MicroPython, is that it's really difficult for embedded work when you're trying to keep the source code private. So if I were to just put a bunch of Python scripts on it, and in those Python scripts it presented you with challenges and then eventually you got a flag, you can dump all of the source code out of there, and more likely than not, you can probably find the flag that's just sitting in the source code. So we had to figure out a way to make it a little bit more difficult than that, because at that point, the flags are posted on GitHub. You can just get all your points from the badge that way. So the issue is that it exposed too much. And I played around with the idea of obfuscating the code quite a bit, trying to hide the string with XORing, and just trying to make it so that while it's still in Python, it was really difficult to find the flag inside of it. And there is essentially no good way to do that because you can always just run the code to get it back. So we had alternatives like the MPy files, which is like machine code compiled MicroPython. The problem with that is it's super duper easy to reverse. You can basically get the source code back out of it. And obfuscating wasn't really an easy solution either. So we essentially had to decide the painful realization that we're going to have to write all the CTF challenges in C, and we're going to have to compile them into the MicroPython binary and try to make it all work together in a nice bundled package. That was quite the undertaking. There were a lot of problems involved, including screaming badges where you just turn it on and the badge would make a high-pitched screaming sound until you turned it back off. That was a really fun one to debug on Tuesday. So we decided we would go ahead and write some custom code, and that's what I spent many sleepless nights working on for this, for the badge. So what we ended up doing was this is the custom MicroPython binary. Okay, so at the base of our lovely pyramid, you can see that we're running MicroPython 1.26. So MicroPython itself is actually implemented as like a C implementation that is compiled and then presents you with all the beautiful, super easy to use parts of Python. So I totally understand why you guys went with Python. It's very, very easy to just walk up and start using. But if we compiled this in Rust or we just kept it in C like on an Arduino, it would have made my job a lot easier for next year. So. But no, Python is super easy to approach, and I'm really glad that we picked it for that matter. And so MicroPython is an excellent project that you can actually use on any of your embedded projects already. It basically puts Python with some limited features onto your embedded project, and then you can run anything you would normally run. So as we discussed earlier, we have a custom display driver. Everything else I thought we handled pretty well, but when we got to the displays, we thought we were going to have to interact with this thing on the IC2 bus and basically build our own driver in Python. And luckily we did find that repo from Russ Hughes, and so we went ahead and pulled in a C-based user module for the displays. And that's why the displays work as well and they're as fast as they are. So on top of that, we went ahead and built out our custom CTF C-based user driver. And then all of that gets compiled together into the binary that actually shipped and flashed on all of your badges. So this is all available on the GitHub, by the way, so it's super easy to find, but I won't tell you the flags. So for our challenges, kind of like Steven, I had a couple different users in mind. We wanted to make sure that anyone who participated in the CTF and wanted to play with the badge could put some points on the board. So we had a couple different challenge concepts here, and I have to be careful about what I share, but from our first challenge, it's a super simple concept of if you can just explore the badge, you can get a flag. So if you can explore the documentation, if you can just connect to the badge and look at the files on the file system, you can put points on the board in the CTF. So I really want to encourage everyone that you can participate if you'd like to, and you definitely should. Those are for first-time badge users, people who aren't really interested in the CTF from a competitive aspect. From there, we have a couple small apps that are on the badge. Some of them are just, can you interact with the badge through the serial interface? And then a couple more are, can you interact with the badge by writing an application on the badge that will give you back what you're looking for? So can you reverse engineer some of the pre-compiled apps and see, oh, I can see where they're interacting with machine code, and how can I get a flag back out of that? And so those are for some of the new users of MicroPython. You're comfortable with MicroPython, but you're not exactly going to dive into a CTF. Past that, there's a couple complex, more advanced challenges where you're going to have to interact with the badge using, frankly, complex and maybe over-contrived C code. And you're going to have to interact with the library to pull the flag out of it in a more advanced way. And so those are for actual people who are really interested in both the embedded development side and also the CTF side. Those are high scoring challenges, and we really wanted to reward people for going through the pain that is some of these challenges. Then the last one is more of a traditional CTF player. It's some binary reversing, some cryptography. All of that can be done without the hardware of the badge. You can just pull it down from the GitHub, and so that's going to be for some of our even more advanced users who are looking for more of a traditional CTF style challenge. So those are the challenges that we created, and I really wanted to just get up here and encourage people to participate in the CTF and really play around with the badge, because any ideas that we get this year will fuel what we do next year, and I'm really excited to see what we do with it. So I'll go ahead and turn it back over to Steven here.
All right. Hey, one other thing I want to talk about, and I want to show you guys something else we did here. You know, I'm sure there's a wide variety of technical backgrounds and experience, and I'm sure for some of you, there's parts of this that are super exciting, and for some of you, maybe you thought your eyes are glazing over, this isn't what you thought it was going to be as far as the talk. But one thing that has been super awesome about this project has been, it's just been such a cool sense of community. Like, I think we've all had a blast doing this, and like, it's so cool to see this come together. You know, we talk about one of the points at BSides is to really build a technical community to help avoid the brain drain, make this a place that people want to be, because we're doing interesting technical things, and I think fun side projects like this absolutely fall under that. So that being said, I just want to show you a little bit of kind of what this was like for us. The best part of it was, I think, in terms of community that we can demonstrate, because we took pictures, was the assembly party, right? So all these badges we had to assemble them. So even though they came with all the components on them, we had to add the screens, because that was a separate component we bought. The 3D printed backs, obviously those had to be 3D printed. Adam Siebold and Dave did all the 3D printing. You did the screen, yeah. So the screen holders were 3D printed in front, that was Dave. Battery covers were Adam. He heat pressed the threaded inserts into like 250 of these. He was doing it with his daughter. It was the sweetest thing ever. He showed us a picture. We had to assemble all that together. We had to put the batteries on, plug them in, screw them in, and then Brett and Luke did all of the charging and all the programming for all these. So this has been a huge effort. So this is just some of us here at the badges laid out at Brett's house. We were basically working all around the basement. Here just doing the battery covers and getting the batteries in them, and that's also where we were adding into the badge. This is the badges all packed in after we programmed it with initial testing. We had planned on programming the final firmware that night, but the software guys weren't done with it yet. So we just programmed the test firmware, and we did the final firmware another day. Brett saved us on that one. I'll show you that in a second. This is literally, all of these little screens came with like a little like film on them, right? And so we have 250 badges, we had 500 screens. So this is a pack of 500 little sticky screen film projectors. This is what Brett bought for doing the programming. This is a 16-port USB hub. He bought 2 of these, so you could program 32 ports at once. This worked out amazingly well. And then Luke wrote an auto programmer that took our programming scripts and basically automatically detected when you plugged in a device and just started flashing it. It worked super well. With the test framework, it was like really fast to deploy. And so literally, you were like taking longer to move the badges than it would take them to flash. So you were basically running back and forth. It was almost just a problem of how fast could you even move the badges. So that worked really, really well. And then Brett set it up. We realized that the issue was not even so much about technical throughput. It was literally just a kind of a positioning control problem, right? And so Brett taped everything down when we were just trying to program it to have a really good setup, because we kept getting our cables all mixed up, but we just had a real jumble that first night we did it. But we learned how to do that. So Brett got this set up real nice, and then he set up another table so he could program 32 at once. It took us it ended up being about 2.5 minutes, I think, to do the full programming. So the fresh firmware that Tad and I got finished, all the MicroPython code, it was like 2.5 minutes. But honestly, so like you guys were like 2 hours, right, to do all of them. It was amazingly fast. So it's super, super cool that he came up with all that and got all that working correctly. So we even had a little like time lapse here, the badge party. It's just like 30 seconds, so it shouldn't be too long. You see my ugly mug there at the beginning. Oh, it's like zoomed in here too. But anyways, it was just fun. Like, you can kind of see us staging the badges. They all started over here with the displays. So that table is full the longest. You can see badges kind of come and go from that table. And then this is where we're doing the battery covers. Luke was over here doing some software testing. So you can kind of see, at one point we all went and ate pizza and Adam just kept working. Like, he was just crushing it. And we're all eating pizza right there. So that was pretty funny. So yeah, you can just kind of see the badges just flowing around the room, man. It was a huge effort. We also had Steve and Milo were there. There was a bunch of us there. My kids were there. They were just reading books, so they were being lazy. It was crazy, you know? Gotta put your kids to work more, right? So anyways, no, we did good. We got them all around the table there. You can see eventually it clears out, and that's the end of it. So that was about 3 hours and 20 minutes crunched down into 40 seconds. So anyway, let's start again. I want to see my face again. Okay, and Brett, I went ahead and added the GitHub since you asked. I added this slide here at the end of my phone. So this is the GitHub address. Again, there's a QR code out there where you can scan it. And we are now ready for Q&A. We only have about 10 minutes left, but we will do our best. So, let me go with the mic. If you have a question, I can bring you a mic. Or you can just yell.
We have mics, we have people out here with mics. So I'm going to ask some questions first,
Yeah.
or do you want to do the audience questions?
No, go ahead. You got questions you want to ask. What do you think? Yeah, what do you think?
So, had a couple of questions that we wanted to go over. This is for Luke, Steven, or Tad. So you guys can decide who answers it. How many hours do you think you worked on the badges?
Okay, I'll start with this. So, like, here's the reality. Like, I actually ended up being kind of like in between contracts the last couple months, so it actually worked out really well. I was able to put a lot of time into it. It had to be at least 80, which I don't know. Maybe it doesn't sound like a lot, but it was a lot. But it was a good project to keep me busy. I was doing some part-time stuff, and it kept me busy, it kept me entertained. So.
Yeah, I couldn't even make a guess. Honestly, it all blurs together. So probably around the 40 mark at least,
Yeah.
but I couldn't even make a swing at the total.
Yeah, I couldn't make a guess either. Probably around 40 or 50.
The amount of time that you spend thinking about it in between meetings, and I just thought of something I'll do over my lunch, and I'll just work on it a little bit later into the evening. It all adds up so much. I don't think I could even guess.
Yeah, a lot.
This one's for Brett. What was the biggest hardware challenge you encountered designing the badge?
I would say it was the incident we had with the V3 badges, and I'll call it capacitance issues on the serial lines. So on V3, the serial interface was all the way down here at the bottom, and it went right into the CH340, and then converted it to TXRX3 or serial line UART. And that rode all the way up the side of the badge to the ESP. And on V1 and V2, it was the same way, but it worked fine. There was no problem. But on V3, it did not. We still have a couple of V3 badges that we could not get to flash. We had to lower the baud rate down, and NP Remote doesn't even support different baud rates. I don't know what is up with that. It's weird. But it was weird because everything worked fine until we had a meeting. I had already, we had everybody come over to my place, and we were going to discuss the to-dos. And nobody's badge worked. And I was like, what is going on? We were all trying to figure out what was happening, but eventually, I got the oscilloscope out and actually monitored the actual edge of the serial pulses that were going through, and there was a little bit of a curve. And it wasn't enough. It was just barely enough to say, yeah, it's gonna corrupt the data. So I had to really quickly redesign where that is, and order another revision, because V3 was supposed to be the final, but it wasn't, V4 was. So yeah, that was a tough one.
I've done a little electronics design and troubleshooting in my time, and let me tell you, there is nothing that will make you believe in the supernatural than trying to debug a weird noise issue in your surgery. We were like, what if I stand on one foot? What if we take those batteries out of the room? What if I sit on that chair? I was like,
Well, yeah, we did. We actually took the batteries out of the room because we thought, I just ordered the batteries, and there's a big stack of batteries in the middle of the table, and I'm like, those have components in them. Like, they have protection circuits. I'm like, maybe that's messing with us. We took them out, and it's still messed up. So
It was crazy stuff. But it was fun. All right, so Luke, Steven, and Tad, what techniques, tricks did you use to optimize performance and how memory on limited microcontroller hardware?
Writing it in C and thoughts and prayers. That's what I use. It's small.
On the MicroPython side, so if you know Python code or you get into Python code, basically when you're in a specific script, you're going to import other scripts. Well, when you import that script, it actually basically has to parse that entire other script, right? So you think of it like, okay, you need to read this book, and now you also have to read the other book before you read this book, right? It's going to take longer, you have to read both books. Okay, that's basically what I'm getting at. So the idea was, well, how can we just kind of know what's in that book without actually reading it, right? And that's where the app cache came in. So that was that whole idea of that structure. So yeah, if you're interested in that, I'd be happy to talk to you more about it. So
Yeah. Do you want to say something real quick?
I can't really think of much. The only thing I can think of is with the displays, which this is more of Steven's thing. But we used a a frame buffer, it improved the performance of some maps. It like, I don't know, can you explain that better?
Yeah, totally. Yeah. So in development, a lot of times, especially when your slow point is going to usually be sending the data over the actual wires, right? It's going to be really fast to assemble things in memory. And what happens is that when you try to do multiple writes to the display, you try to write this thing and then write that thing and then write that thing, there's overhead for each one of those actions that you do. And so a way to improve that is to basically compile what you want the whole screen to look like in memory in what's called a frame buffer, and then send the whole frame buffer all at once. This also avoids flickering, because a lot of times you get some refresh kind of artifacts that show up. And so you'll often hear terms used in this area like double buffering. We were essentially double buffering, where the one buffer was what was being held in the display itself was holding the existing frame, while we were assembling the new frame before we sent it. And I think we found we were measuring our in like frames per second, and I think we took some apps from like 5 to 6 frames per second up to like 14 to 15 frames per second. And we did find we could get upwards of like 40 some frames per second if you just redraw certain portions of the screen. So another goal we have for next year is, can we do some more animations and things like that on the board just to add interactivity to the UI. So.
Yeah, so you hear that? They're already thinking about mixtures badge and how to make this one even better. So stay tuned for that. Are there any questions real quick? We only have a couple minutes. Are there any questions from the audience?
We got one in the front here.
Okay. You want to go to Milo first?
Sure.
All right. Justin, you come up and help in a second.
Do you think it'd be like entirely possible to understand the basic fundamentals of like doing stuff with the badge just today if you don't know any prior knowledge about MicroPython, or would that not be possible?
Yeah, totally. Python's a super easy to use language. A lot of programming languages have a lot of extra things in them that are really confusing for people to read. Python reads really nicely. And so I think it's really easy for people to understand, especially if you've done any kind of programming in the past. It's really easy to use. And if you just talk to someone in the badge hacking village, I'm sure they'll be able to get you started. I'm confident we could get you to write an app today. In fact, I can show you probably in about 2 minutes how you can even use the web interface to copy the Hello World app and deploy your own version of it. Just change the text or something in a pretty short amount of time. That'll start at least get you on the right path. So.
My question was somewhat similar, except on the hardware side. So, are there any good resources to learn how to do badge engineering at the hardware level? And also, how do you learn the dark art of laying out a circuit board? You know, because you know, I'm involved with a DC 937 and a couple of other DEF CON groups. And we were thinking about doing a badge, and the collective knowledge of how to do that doesn't seem to be there. Any thoughts?
Yeah, so as far as like things specific to badges, I haven't found a lot out there about that, but specific to designing microcontroller boards, there's a lot of data out there. So there are some YouTube channels that are really good, and I honestly thought about putting them up there, but I can share those. I can actually put those on the Discord and give you a couple.
Awesome.
Yeah, because I mean that's usually when I'm trying to figure something out, I'll go search for it first, and if I don't like find exactly what I'm looking for, I'm like, all right, somebody has done this before. I go and find the YouTube of the guy who actually took the time to do it. Yeah, that's definitely how I do it. As far as like hardware design and getting into it and figuring out layouts, it's trial and error a lot. It really is. Like with the serial lines, you know, you think you've got it right, and then you realize you don't. And then you order a new board.
Well, we're out of time, so we need to go ahead and wrap up and get ready for the next session. If you have more questions, come find us in badge hacking. You know, Brett will be down at the GigTel booth. Just a reminder, hit up our vendors out there again.
On the Discord too, after the event. Feel free to hit me up if you got questions.
Thank you all.
Thanks everyone.